All right, guys, we're going to look at 20.1, connecting intercepts and zeros. So we're actually starting off on page 937, and we will go until 939. So make sure that you have those pages. We're going to get started with the Explorer, so graphing quadratic functions in standard form. A parabola can be graphed using its vertex and axis of symmetry. Use these characteristics, the y-intercept, and symmetry to graph a quadratic function. So we're going to graph y equals x squared minus 4x minus 5 by completing these steps. And so go ahead and write these steps with me. So for part A, for finding the axis of symmetry, we know that we're going to use x equals negative b over 2a. And so if we look at our original quadratic equation or function here, we know that a is going to be 1, b is going to be negative 4, and c is going to be negative 5. And so if we plug that in, we have negative 4, and then 2 times 1. And so we're actually going to get a 2, because if you see this, we have a negative times a negative, so that becomes positive, and so we get 2 here. And so the axis of symmetry is x equals 2. So now we're going to find the vertex, and what we're going to do is we're going to plug in our axis of symmetry to our original quadratic function. And so we're going to have 2 squared minus 4 times 2, right? Because remember, this is x, minus 5. So 2 squared. So 2 squared is just going to be 2 times 2. And that gives us 4. A negative 4 times 2 gives us a negative 8. And then minus 5. And so we should get a negative 9. Okay? The vertex is 2, negative 9. Because remember, this is x, and this is what y equals. Okay, so let's go ahead and continue on. So we're going to find the y-intercept. I don't know if you guys remember, but when we found the y-intercept, or when we find the y-intercept, we have to plug 0 into x. And so every x is going to equal 0. And so 0 squared is going to give us 0 minus 0 minus 5. And so our y-intercept is going to be negative 5. And the graph passes through 0, negative 5. Okay. And so for part D, we're going to find 2 more points on the same side of the axis of symmetry as the y-intercept. So find y when x is 1. And so we're going to plug in 1 for every x value. So we have x squared minus 4x, which we're plugging in 1 for, minus 5. And so we have 1 minus 4 minus 5. And so we should get a negative 8. And so the first point is 1, negative 8. The second point we're going to look at is we're going to plug in a negative 1 for x. And so we're going to have negative 1 minus 4 times negative 1 minus x. And so we have 1 minus 4 minus 5. And so we're going to get a positive here. And so we have a 0 because 1 minus 1 equals 0. And so our next point is going to be negative 1, 0. Okay. So now we're going to graph the axis of symmetry, the vertex, and the y-intercept, and the 2 extra points on the same coordinate plane. And so by doing that, we're going to start at 2, negative 9, because our vertex was 2, negative 9. Our axis of symmetry was 2. Our y-intercept was, let's go back and look at it. Well, our y-intercept is 0, negative 5. And then our 2 points are going to be 1, negative 8, and negative 1, 0. And so if I plot my vertex, I'm going to go to -2, and I'm going to go down to, or +2 down to -9. Sorry about that. Well, we already know that this is our axis of symmetry, which we can also write it as x equals 2. Okay. We're going to plot our y-intercept, so we're going to find 0, and we're going to go to -5, which is going to give us this point here. Then we're going to go to 1, -8. And I just plotted that at 2, -8, and so I'm going to go to 1, which is here, and -8. So we're going to be about here. I'm going to go to -1, which is about here, 0. And I know because it's symmetrical, I'm going to have a point here, I'm going to have a point here, and I'm going to have a point here. And I'm going to be able to connect those and graph my function. Okay. So we're going to go ahead and get some practice with this, but keep in mind that it's all to graph it. So then reflect the graph points over the axis of symmetry, which we did because our axis of symmetry is here at 2. And so if we have a point here, we're going to have a point here. If we have a point at 0, -5, we're going to have a point at 4, -5, and so on and so forth.